How does optical emission spectroscopy work? Step 1. Spark excitation. Under a high-purity argon atmosphere, a high-voltage spark generates instant plasma exceeding 10 degrees Celsius. It melts, vaporizes and atomizes the metal surface to excite characteristic spectral lines unique to each element. Step 2. Dispersion and separation. The composite light beam enters a sealed, vacuum, or argon-purged optical bench, where a high-precision grating conducts spatial dispersion to resolve discrete wavelengths of each element's spectral lines. Step 3. Photoelectric conversion. The separated spectral lines irradiate high-sensitivity (CCD) CMOS solid-state detectors, which rapidly convert optical signals into quantifiable electrical signals for data processing. Step 4. Quantitative analysis. Based on fundamental spectroscopic quantitative principles, the software collects real-time spectral intensities and compares them with pre-calibrated standard working curves, outputting the precise mass fraction of each element within seconds.